PARCC sample questions. The remaining slides in this presentation contain questions from the PARCC sample test. After finishing this unit, you should be able to answer these questions. Good luck! The figure shows two perpendicular lines, S and R, intersecting at point P in the interior of a trapezoid. Line R is parallel to the bases and bisects both legs of the trapezoid. Line S bisects both bases of the trapezoid. Which transformation will always carry the figure onto itself? Alright, well, if you reflect across this line, that would work because this point would move there, this point would move there, and all of these would fill in. It would reflect perfectly across line S. However, it's not going to reflect properly across line R because that would then put the short base on this side and the long base on top, which would not be the same. It wouldn't carry the figure onto itself. And we can't rotate 90, 180, or 270 degrees because if we rotate a trapezoid 90 degrees, that would be this way. That would put the long base on the right. If we rotated 180 degrees, that would put the long base on the top. And if we rotated 270 degrees, that would put the long base on the left. So none of these are going to look exactly like the original. The answer to this question is just B. In the coordinate plane, triangle ABC has vertices at 1, -2, 1, 0.5, and 2, 1. And triangle DEF has vertices at 4, -3, 4, 2, and 6, 3. Select from the drop-down menus to correctly complete the sentence. The triangles are similar because triangle DEF is the image of triangle ABC under a dilation with what center and what scale factor. Alright, so in problems like these, I like to draw it out. So we have an axis here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Okay, so let's sketch out these triangles. ABC is 1, -2, so here. 1, 0.5, so there. And 2, 1, here. All right, so we have our triangle that looks like this. All right, and the next triangle is 4, -3, 2, 3, 4, -3, 4, 2, and 6, 3. So up here. All right. So there's DEF. DEF. And I'll label the first triangle 2. This was ABC. Okay, so we have a dilation for sure, and it's an enlargement. So let's draw lines to figure out where the center of the dilation is. So we can take a line from E to B through like that, F to C through like that, and D through A. So the center of this dilation is not the origin, it's over here. Now, it's hard to visualize exactly what it is because it's not, obviously this is just like a sketch, but here we have a couple options. This one, -2, -1, seems to be the closest one because 1, -2 would be over here, the origin's up here. I would say the answer here is C, -2, -1. And what is the dilation? Well, what is the measure of this side here from A to B? It goes from -2 up to 0.5, so this is 2.5. And what's the measure here? It goes from -3 up into 2, so this is 5. So 2.5 and 5, you multiply 2.5 times 2 to get 5. So the dilation has a scale factor of 2. So we multiply every side here by 2 to figure out the sides here. So the answer is C and D. Triangle ABC is shown in the XY coordinate plane. The triangle will be rotated 180 degrees clockwise around the point 3, 4. So it's going to be rotated around this point 180 degrees. So that would create a triangle that looks something like that. So that would be C prime, B prime, and A prime. Indicate whether each of the listed features of the image will or will not be the same as the corresponding feature in the original triangle by selecting the appropriate box in the table. The coordinates of A prime will not be the same. The new A prime will be over here. The coordinates of C prime will be exactly where C is. This point here does not change. The perimeter of the triangle does not change because this is a rigid transformation, which means the area is also the same. The angles inside the triangles are also the same, and the slope of this line will be the same because it just continues on like that, one straight line. So there are our answers. The figure shows line AC and line PQ intersecting at point B. Line A'C' and line P'Q' will be the images of lines AC and PQ respectively under a dilation with center P and a scale factor 2. So let's draw A'C'. So we're going to draw rays from P, which is the center of dilation, through the points A and C, like that. I'll extend this a bit. Okay. The scale factor is 2, which means, well, let's just draw our line. All right, so this length here, if that's x, then the length here will be 2x. So about twice that distance. Maybe we should use our compass. No. Okay. Compass. We will, like this. I'm just using the compass to measure this distance. Then I'll pick this up, move it over here, and then I'm going to flip it around one more time. That's where our point's going to be. So that we used 2 of these distances here. If this is x, then here, I'll get rid of this compass. So if this distance was x, then this distance is 2x. We have our point here, and we'll just draw a line that is parallel to this line. So it's going to look like about like that, just eyeballing it. So this is A prime and C prime. Line A prime C prime will be parallel to line AC. However, then we have line P prime Q prime. Now, if you have a dilation with the center on the line, then the line's just going to be the same line. You're not going to get a new line when you're doing a dilation with, if the center P is on the line, it's just the same line. There's no second line, so it's going to be the same line as PQ. In the coordinate plane shown, triangle ABC has vertices at -4, 6, 2, 6, and 2, 2. What is the scale factor and center of dilation that will carry triangle ABC onto triangle DEF? Enter your answers in the boxes to complete the sentence. All right, so what's the scale factor? Well, let's just take one side of this triangle, and that is 1, 2, 3, 4. Then we will take that corresponding side of this smaller triangle, and that's 2. So we take the red number, put it over the green number, and we have a scale factor of 0.5. Now, to find the center of dilation, we can just draw lines through the vertices. So A through D, like that. We have B through E, and we have this point there through there. So we can see that the center of the dilation was right at the origin, 0, 0. Triangle ABC has vertices at 1, 2, 4, 6, and 4, 2 in the coordinate plane. The triangle will be reflected over the x-axis and then rotated 180 degrees about the origin to form triangle A prime, B prime, C prime. What are the vertices of triangle A prime, B prime, C prime? All right, so let's draw a picture. All right, and how many units are we going to need? It goes up to 6. Okay, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I will extend this line. All right, now let's draw our first triangle. 1, 2. 4, 6. 1, 2, 3, 4, 5, 6. And 4, 2. So here. All right. There we go. Now we're going to reflect it over the x-axis. So let's do that first. So that would put this point here, this point here, and then this would be, this point is at 4, 6. So that would be at 4, -6. 1, 2, 3, 4, 5, 6. Okay. So here is our reflected triangle. Now we will rotate it 180 degrees about the origin. Let me very quickly write out all these points so far, just so that we don't get confused. So this is 4, 2. That was 1, 2, and that's 4, 6. So now this is 4, -2. This one is 1, -2, and this one is 4, -6. Now we're going to rotate it around, so the signs are going to change. So when we rotate 1, -2, it becomes 1, 2. Let me do a different color here. All right, this is 4, -2, so that will become -4, 2 up here. And then this is 4, -6, so that'll be 4, -4, +6. 1, 2, 3, 4, 5, 6. All right, so here is our final triangle. What are the vertices? So this one was -4, 6. This one is -4, 2, and this one is -1, 2. All right, so -1, 2. This one, -4, 6, and -4, 2. The answer to this is C. Triangle ABC is graphed in the coordinate plane with vertices A at 1, 1, B at 3, 4, and C at -1, 8 as shown in the figure. Part A. Triangle ABC will be reflected across the line y = 1 to form triangle A', B', C'. Select all quadrants of the xy coordinate plane that will contain at least one vertex of triangle A', B', C'. Alright, so let's reflect this across the line y = 1, which is there. Alright, so this point is going to reflect onto itself since it's on the line of reflection. This point is 3 units above the line of reflection, so if we count 1, 2, 3 units below, that's our new point B, which is B', that is at 3, -2. And then this point is 7 units above, so if we count 7 units below, 1, 2, 3, 4, 5, 6, 7, that's our new C' down here. So let's connect those dots for our new triangle. All right, there we go. So, which quadrants contain points A, B, and C? A is in quadrant 1, B is in quadrant 4, and C is in quadrant 3. So, 1, 4, and 3 contain points in triangle A', B', C'. And then what are the coordinates of B'? Well, let's go look. 3, -2. Quadrilaterals ABCD and EFGH are shown in the coordinate plane. Quadrilateral EFGH is the image of ABCD after a transformation or sequence of transformations. Which could be the transformation or sequence of transformations? Select all that apply. A translation of 3 units to the right followed by a reflection across the x-axis. So if we did that, say to point C, 3 to the right, and then a reflection across, so this would be 6 units below. And no, this point does not end up there, so we can cross out A. It's not A. A rotation of 180 degrees about the origin. All right, let's see. So if we rotated this about the origin, it would be 1, 6. It would be over here. Yes, that looks good. B would be at well, we have 3 and 7, so 3, negative 7. Yes, that does line up. A is at negative 4, positive 4, so that'd be 4, negative 4. Yes, that also lines up. So yes, 180-degree rotation would work. So we can check B. A translation of 12 units downward, followed by a reflection across the y-axis. All right, so 12 downwards, let's see. A would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then a reflection. There's no point over here, so that one does not work. Cross that one out. All right, a reflection across the y-axis followed by a reflection across the x-axis. All right, so if we reflect D across the y-axis, we get D prime here. We would get A here. C, here, let me delete this point from earlier. All right, B would be positive 3, and C would actually flip over to this side, so this would be our new shape. And then we would reflect it across the x-axis. Yes, that would work. Once this is reflected across the x-axis, it would line up here. So yes, D does work. A reflection across a line with equation y equals x. Well, that would be across this line here, and so C would end up over here. So that one will not work. So our answer is B and D. All right, we're going to use the same graph here for part B. Quadrilateral ABCD will be reflected across the x-axis and then rotated 90 degrees clockwise about the origin to create quadrilateral A prime, B prime, C prime, D prime. What will be the y-coordinate of B prime? All right, so first we're going to reflect this across the x-axis. So D moves there, A moves there, D, we have B, which will go down here, and then C will be over here. Okay, so here's our reflected figure. Now we're going to rotate this 90 degrees clockwise, so this way. So D will move back there, A will move back there, B is going to, so we're at negative 3, negative 7, so it'll be positive 3, negative 7 over here, and then C is at 1, negative 6, so we'll be at negative 6, negative 1. So here we've rotated it. The question is asking for the point B. So B was here, but once we rotate it, it will be up here. The coordinate here is negative 7, 3. So if we want the y-coordinate, that would be 3. In the coordinate plane, line P has slope 8 and y-intercept 0, 5. Line R is the result of dilating line P by a factor of 3 with center 0, 3. What is the slope and y-intercept of line R? All right, so let's draw a little graph here. All right, let's draw some units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have our y-intercepts at 0, 5. 1, 2, 3, 4, 5. And we have a slope of 8. So I'm just going to draw a line that looks like this. Okay, so we're going to dilate this line with the center 0, 3. Now, this becomes a lot easier if you dilate from the origin. So instead of dilating here, let's shift everything down 3 units, dilate from the origin, and then shift it back up. So we have our new line is going to be 3 units lower, 1, 2, 3, like that. Now, this point there is 0, 2, because we were at 0, 5, and then we went down 3 units. Now, if we dilate this point here from the origin with from a scale factor of 3, that becomes 0, 6, which is up here. But then, so then we have that line dilation. Let me draw that. I'll draw that in red. Here, let's have to move it into place. Okay, but then we have to move it back up 3 units so that we have our correct answer. And that will be in purple, 1, 2, 3. All right, so here's our new line, and that has what y-intercept? So if we had 0, 6, and then we went back up 3, that would be 0, 9. And remember, all these lines here have the same exact slope, which is 8. So we have a slope of 8 and a y-intercept of 0, 9. The answer is C. Triangle KLM is the pre-image of triangle K'L', M', before transformation. Determine if these two figures are similar. All right, so let's see what it is. Well, it's definitely a dilation, so we can cross out D and E. It's a dilation, and it's not going to have a negative scale factor, and it's also not going to have a scale factor of 1, because that would be the same size. So we're dealing with a scale factor of 1.5 centered at the origin, and they are similar because this does work. So for example, this triangle has a point at 8, and this point L prime is at 12. So 8 times 1.5 does give you 12. So yes, these are similar triangles with a dilation of scale factor 1.5 centered at the origin. A and C. Line segment AB with endpoints A at 4, 16 and B at 20, 4 lies in the coordinate plane. The segment will be dilated with a scale factor of 3/4 and a center at the origin to create A', B'. What will be the length of A', B'? All right, so we have A at 4, 16. We have B at 20, 4. To find the coordinates of A', you just multiply each of these by 3/4. So 4 times 3/4 is 3. 16 times 3/4 is 12. B' would have 20 times 3/4 is 15. 4 times 3/4 is 3. All right, now we can use the distance formula. So we have 15 minus 3 is 12 squared, plus 3 minus 12 is negative 9 squared. So the distance equals the square root of 144 plus 81, which is the square root of 225, which is 15. The answer is A. A dilation centered at point C with a scale factor of K, where K is greater than 0, can be defined as follows. Number 1, the image of point C is itself. That is, C' equals C. Number 2, for any point P other than C, the point P' is on ray CP, and CP' equals K times CP. Use this definition and the diagram shown to prove the following theorem. If line segment A', B' is the image of line segment AB after a dilation centered at point C with a scale factor of K where K is greater than 0, then A', B' equals K times AB. Be sure to explain how you would use the diagram to prove the theorem and show justifications for each statement in the proof. Enter your proof, your explanation, and your justifications in the space provided. All right, I'm going to move this image over the diagram so we can read the answer while also looking at the picture. So we begin with our given information. We also know that CA', this length here, equals K times CA, and CB' equals K times CB. So we can then divide, because of the division property of equality, we can divide both sides by CA here and both sides here by CB. And that we can then set these equal to each other because since they're both equal to K. So CA' over CA, so this length over this length equals this length over this length. And we know that angle C is congruent to itself because of the reflexive property of congruence. Therefore, these two triangles here are similar because of SAS triangle similarity. So because of the definition of similar polygons, we can then create this ratio, A', B' over AB equals CA' over CA equals CB' over CB. Then we have, because of substitution, A', B' over AB equals K, since we know that these are equal to K. Therefore, if you multiply then both sides by AB, we get A prime B prime equals K times AB.